How do we get ourselves allowed to build the buildings we know solve the transportation energy problem where we don't have to drive everywhere? How are we allowed to build buildings in downtowns again like we did 150 years ago all across this country? That's the puzzle that has like really got me going, is how do we allow ourselves to keep doing what our grandparents were allowed to build?
Hello and welcome to the Reimagine Edit, a special series of the Passive House podcast that shares curated insights from the conversations happening in the Reimagine Buildings Collective, our membership community, where we bring together builders, designers, and change makers who want to create healthy, climate-ready buildings so that we can share hard-won lessons, level up our practices, and build the networks we need to thrive. Today is August 5th, 2025, and in this episode, we'll hear from Cameron Caja, Jacob Racusin, Josh Salinger, Jesse Thompson, and Melissa Furukawa. I'm Zack Semke, Director of Passive House Accelerator and host of the Reimagine Buildings Collective, and thanks for joining me. Alrighty, let's start with an excerpt from one of our newest experts in residence, Cameron Caja of Positive Energy. In his recent Ask Me Anything session in the collective, he was asked about whether dedicated dehumidification is necessary on projects.
We address moisture control through the envelope first, right? So we're trying to address the air tightness. We're trying to address uncontrolled openings. And once you've done that in the best way you can, then you move on to the next. And so then we want to control it through active processes. So having a dehumidifier available to you in that home is, it's kind of a cheap insurance policy. At the very least, even if you're not going to be worried about condensation happening within a wall cavity or underneath a floor or something like this, you're probably still going to be worried about the veins on your air handler unit or something like this. Like if you've got a mini split mounted to a wall, you're going to see moisture accumulation there. Those surfaces are going to fall below the dew point because of the coil temperature. And nobody likes to see black mold on those supply registers, and you can control that by controlling your dew point. So yeah, I would say that I've not seen a situation where having a dehumidifier would be a negative. Like, just if you're at all worried about it, just put one in, even if it's a portable, like roll around kind of thing that you're going to have to empty the tank. That's not ideal because it could fill up and it's going to get away from you. But it's such a cheap insurance policy. Again, we're talking about $1,000 or something, and it'll take care of you.
Makes sense. Cheap insurance. Next up, we hear from Jacob Racusin of New Frameworks Design Build and the co-developer of the BEAM estimator tool for embodied carbon, among many, many other hats he wears in the world of building decarbonization and natural materials. In this clip from his Reimagine Materials interview with Michael Ingui, he shares where he's seen resistance to taking action on embodied carbon, as well as a bright spot in that picture that may shine a path forward.
Embodied carbon reduction has always been foundational and is now like becoming a really, really, really important thing to define and name, partially because that is how we're going to achieve better buildings at cost, as if we can think about more than one thing at a time, but really because now that embodied carbon is becoming more initiatives are occurring, is becoming more popular, there is perhaps unsurprisingly more pushback. And a lot of that pushback is actually coming from within the energy community for folks that see embodied carbon as tangential and not related to energy, or that see it as a direct threat and a distraction from the focus on energy reduction from a point of like policy or strategy for moving the industry forward, or that see embodied carbon as a dilution of climate impact reduction from the energy space. So you could literally trade carbon like metrics. I can use less insulation by using a bio-based insulation, and there's a trade-off there. And those three narratives are having providing some really significant resistance to some of the forward momentum around embodied carbon in the market and in the policy space. So I'm going to start by framing that as I name both what's happening and also the direction we're going towards and how things can combine closer together. So there have been a series of different embodied carbon initiatives moving through the I codes, IBC, IECC, that are being heavily challenged. Actually, the IECC initiatives were shot down for 2027 cycle. The IBC versions are, we'll see, they haven't been shot down yet, but they're under a lot of resistance because of the reasons I just mentioned. Those are like kind of the primary reasons that are being put out there, which is really fascinating to look at that in contrast to what's happening through the ResNet organization. ResNet is they administer the HERS program, Home Energy Rating System. So their bread and butter and roots are as doing energy assessment on residential construction. There is a embodied carbon standard, ResNet standard 1550, which is a standard for how to conduct embodied carbon assessments by energy raters. That is moving forward very strongly with like broad consensus support amongst production home builders and energy people and regulators and folks deep within the ResNet community and within the residential space, seeing that, oh, not only are these things directly related, and that we need to figure out how to optimize for both energy and carbon, operational and embodied carbon, but that it is quite literally the energy professionals that are going to be able to most effectively scale that work out and do that work effectively within the residential space. And so that the development, that standard went through a round of public comments. Thank you for all of you who provided comments. It has now been synthesized through the technical committee, and the standard has now been is very shortly going to be released, like within the next weeks to month, is scheduled to be released for another round of public review. God willing, that moves forward smoothly. In which case, I'll invite all of you, please keep your eyes out for that, because we want that additional review, because we want that standard to be codified, because that is likely going to position the residential sector to be the leading sector for conducting embodied carbon assessments at scale, and do that harmonized within an energy rating organization, and really bring those things together in a very structural way, as well as within the level of the workforce. On the BEAM side, I'm working right now with our team to redevelop BEAM, get it off of Google Sheets so it's a much more stable and functional platform, and design it to be able to be compliant with that standard once it's released, and working really hard now to coordinate the development of that tool with energy modeling tools. So it's as frictionless as possible for someone working within, say, a HERS energy modeling tool to be able to then also create an energy assessment using the BEAM tool.
Definitely keep your eyes out for ResNet Standard 1550. Super exciting, and thank you to Jacob for moving it forward. Next up, we hear from Josh Salinger, founder and principal at Birdsmouth Design Build in Portland, Oregon. In this clip from his Reimagine Construction interview with Michael, Josh shares how moving from being a builder to a design builder has unlocked efficiencies in the firm's passive house work.
When we first started, worked for third-party architects, and we were just a build team. And so as we got into more high-performance building, we found ourselves like every architect that would show up, we would have to like, wedge, because we'd get a client that's like, oh, I want to get to zero energy, I want passive house. And then they would hire an architect and they come up with a design. And then we'd have to wedge this performance into that design. And you can do it, but it was not cost effective, nor easy, because oftentimes it meant having to like mess with that architect's drawings, assemblies or whatever, or maybe it had been engineered already and we had wanted to re-engineer some stuff to avoid some thermal bridges. And like, it just was clunky and expensive, and it made it seem like high performance building was expensive, when in reality, you design something that wasn't high performance and we're trying to shoehorn it into that, and that's expensive. And so, we ended up like, we would find some architects that were game and would get into it early, and we could really educate the architects and clients early on so they could deliver a lot of these things to us. But then we found ourselves spending so much time educating architects that at some point in time, it was like, what are we doing? Let's just do this ourselves. So then we brought the architecture in-house, and that's when we really learned the beauty of like the design build process, because then you really get like accurate pricing right off the bat. You can start, defining what a budget could be, and then really working to hit a design that delivers the program that the client wants within those cost parameters, while still delivering that high performance. And like the premium to get to that high performance through the design build methodology just dropped so much, and so for us, it just made tons of sense. And as soon as we started doing that, we started kind of tasting how nice that was. And then we just finally, we were like, okay, we're not really working with third party architects. Now we still do from time to time, but usually when we do that, it's kind of the exception that proves the rule. We're like, oh yeah, we'll work for X architect. This is a great project. And we go through it and we're just like, oh God, this is so inefficient. And it's not like it has to be. It's just that we have developed a process that works so well for us. It goes back to my comment earlier about like whatever works for your team, leverage and do, like we have done that and refined it over time for so long that if we have to do something different, it's just not as efficient. So it's not to say that you can't work with an architect and a builder in a really great collaborative way. I mean, you absolutely should. It's just that for us, because we've refined our system down to work so well, that to jump outside of that is just different.
And here's a story of working up the ranks.
There was a guy who joined our team a while back, and he came from a different industry, and he liked what we were doing, and he met me after a talk I gave or something, and he's like, "Hey, can I just sweep your floors? Like I just want to be around it, And I was like, sure. So for 6 months, he sat there like Daniel-san and just swept the floors and cleaned the trucks and hauled the whatever and never complained. But he would like add helpful things and he became part of the team. And, he was at the happy hour and we enjoyed him. And, eventually someone's like, why is Joe like sweeping trucks? Like this guy needs to be doing something else. And he eventually ended up working his way through the ranks all the way up to, the point where when he finally left the organization, he was the COO. So, just find a team, like get in there. Don't be overbearing. Don't have expectations. Don't be like, why am I not? You just get in there, keep your mouth, shut when it needs to be shut and add helpful advice when you can and marinate in the stuff and be helpful. Come up with creative ideas and like, someone will notice, and work your way through that way. I thought that was a clever thing that he did and it worked.
Love the Karate Kid reference there and great advice. Next, we hear from Jesse Thompson, partner at Kaplan Thompson Architects in the other Portland, Maine. Here, Jesse talks about the evolution that he and his firm are going through.
The last 3 to 4 years have been the sea change of, we were energy efficiency people. It's what's the operating energy of the building? How much does it use as it goes along? Miles per gallon of buildings. And when people woke us up to, hey, when you build a building, there's all this carbon inside the building, and it happens right now. What you make it out of is as important as what it does over the next 50 years. That was just such a sea change, and that leads to the biomaterials. That leads to rapid renewables. That leads out, how do we make buildings out of plants in ways that hold up, that are weatherproof, weathertight. That journey and getting, cement out of buildings and steel out of buildings. That's been the journey right now, and is absolutely the push of. We may have solved heating, but how do we solve the thing that happens right now when we build it? But that's that's been the puzzle that just the last years, and I think that's going to continue to go. And then the next obsession is in this country, we've sort of banned a lot of kinds of construction except for fancy single family houses. Why do so many architects work in fancy single family houses? Because you're allowed to build them everywhere. You don't have to go to a planning board. You don't have to go to a zoning board. You can just pull a building permit. In the heart of any city in the country, I can build a 10,000 square foot mansion in the middle of every downtown, but I can't build a 2-unit apartment building without angry neighbors who have legal leverage to stop me. But I can build a mansion anywhere. So that is what I'm obsessed about, is how do we get ourselves allowed to build the buildings we know solve the transportation energy problem where we don't have to drive everywhere? How are we allowed to build buildings in downtowns again, like we did 150 years ago all across this country? That's the puzzle that is like really got me going, is how do we allow ourselves to keep doing what our grandparents were allowed to build and allowed to do it again? Because it's all, apartment buildings are essentially illegal all across the country unless you have a heavyweight team behind them. Someone who can bulldoze through like all sorts of regulatory snarls. And we shouldn't have to do that. You should be able to build a 3-unit apartment building anywhere in the country without asking permission. So things like that are what I'm on.
Yeah, here. You should absolutely be able to build that apartment building anywhere. A really important point. This second excerpt from Jesse offers a new thought, at least a new one to me, on why Passive House doesn't have a materials focus.
Oh, so you mentioned that you did LEED Platinum and Passive House, and sort of what you said about biomaterials. It's always bothered me a little bit that Passive House is thought of as being very green, environmentally friendly, and it's energy conscious for sure, but not necessarily environmentally friendly with regards to the materials. And I'm wondering if the LEED Platinum certification and the Passive House kind of butted heads for that reason a little bit.
I think yeah, my perception is that Passive came from Germany, and in Germany, they regulate materials.
Hmm. Okay.
And they have a whole separate regulation system that they do where they're allowed to just concentrate on energy because there's all these other things taking care of the other stuff.
That makes sense.
In the United States, we invented this incentive program of LEED Platinum to try to, and they did fix materials. LEED got formaldehyde out of buildings.
Mhm.
It got lots of nasty stuff, the VOCs out of paints. It really did it, but they were energy blind. They weren't focused on operational energy at that time the beginning of LEED. Now, of course, LEED realized that and has changed and has, so I was taught them, and that it has all come back together. But my perception is that there's a unique thing where Passive House came from Europe, where they dealt with formaldehyde other ways. They didn't create an incentive program. They just said no, you can't use formaldehyde. So they didn't have to do the heavy lifting inside the program. And in the United States, we adopted it, and yeah, all these programs were all doing one thing because we, for some reason, think it's okay to just put formaldehyde in buildings.
In this last excerpt, we hear from Melissa Furukawa of Peel Passive House. Among her many credentials, Melissa is a PHI certified Passive House component assessor. So if you're a manufacturer looking to get your high performance component PHI certified, Melissa can help. In this clip from her Ask Me Anything session, Michael asks Melissa to describe how that process works.
Let's assume I'm a manufacturer and I had a product that I wanted to have certified. Just if you don't mind, high level, how do people usually work with you? How far along does a product have to be? Because I feel like there's two different types of people who always come to me asking me this. One person who's still really developing their product, and it's still not really on the market right now. But a lot of them are people who have really nice products already, who if they just detailed it a bit differently, could really ramp up and have a certified product.
Yeah. So most of the time, I would say the people who come to us already have a product and they want to get certified. In that case, we do the energy model. So we use a program called Flixo. It's a 2D thermal simulation software. It's the same one that PHI uses. So that's why we use it. And we would do kind of an initial model to see where the frame is at. Sometimes there may be small changes that need to be made, like changing the spacer or adding more insulation or changing the type of insulation that they're using. But usually they're kind of at a point where the frame profile is fixed and they just what small tweaks can we do to get it to Passive House, or what, because there's also different, you can certify it to different climate zones. So maybe they won't cold as maybe they want to go for cold, but they can't quite meet it, so they'll get kind of cool temperate. Yeah, I think we have kind of also worked in more of a consulting role where we can provide advice as they're in design, which can be helpful because before everything's kind of set in stone, there could be small changes to the profile that could be changed that could have a significant impact. So in that case, we could just provide kind of ad hoc advice and do kind of iterative modeling to see, what is the optimal configuration for the frame to meet the standard. Yeah, so that would be kind of a more iterative kind of back and forth. They send us, we need to have some kind of drawings, right, to do the modeling, and then we would send them feedback, this is where we're at. If we did this change, this could be the impact, but we also need to know what's possible from your end. And then once we kind of get a frame that is meeting all the targets, so the target is an overall U value of the frame and at a certain size. So we calculate the U value of the frame, the psi value of the spacer, the U value of the glazing, And then, so then we get the overall U value of the frame. And then we also have to show that that window can be installed in 3 different wall types with minimal thermal bridging. So we have to kind of come up together with 3 different details that are, I wouldn't say thermal bridge free, but like minimal thermal bridging, because that is also shown on the certificate, which is helpful for you as designers, because instead of, if you have a similar wall detail, then you can use those values instead of having to model it yourself. And then once we have all that done, all the window install modeling done, then we submit to PHI. They do their kind of check. They may have some questions, and then you get the certificate.
With that, thanks to Cameron, Jacob, Josh, Jesse, and Melissa for sharing their insights with us over the past couple of weeks. As always, these clips just scratch the surface, so if anything piqued your interest here, please do dive into the full replays of these sessions available in the collective. And if you're not yet a member of Reimagine Buildings Collective, you should join. You'll get direct access to experts and peers who are on the same journey as you with buildings and resilience and climate. Just head over to reimaginebuildings.com to learn more. Things are really taking off in the collective with great dialogue and insights and energy and some really exciting momentum. We grew by 15% this past month alone, so don't miss out on what's going on inside. We'd love to see you. Speaking of joining the collective, a big welcome to our newest members, and it's a big list here. We had a great group of new folks join to take part in the summer cohort of Ed May's Honeybee PH course, as well as in our summer labs, which are our Think and Do tanks, where 9 small groups are co-creating solutions to a bunch of different climate and resilience challenges and opportunities in buildings. We'll have more to share about that in several weeks. But in the meantime, welcome to Maren Nagel, Chloe Hellerman, Jim Bischoff, Clara Mitchell-Enns, Ben Scott, Kimberly Sevilla, Bo Green, Snigdha Bera, Al Mitchell, James Kupferschmidt, Trey Farmer, Paris Remillard, Doug Massey, Christina Robinson, Karen Herter, Tessa Park, Jordan Jackson, Dan Loeffler, Joseph Hopkins, Christopher Brokaw, Sayo Okada, Alvin Aben, Mark Smith, Patrick Osborne, Brandon Pietros, Christine Selig, Wendy Brown, Kyle Edmister, and Ed Edinger. Whew. Welcome to the collective. With that, thank you for listening to this 10th episode of the Reimagine Edit, a production of the Passive House podcast by Passive House Accelerator. As always, please reach out with anything Reimagine Buildings Collective related. What you'd like to see on the platform, any ideas you'd like to share, guests we should invite, courses we should offer. We're building this community with you, so let us know. And don't forget to invite your friends and colleagues to join us. Thanks, and have a great couple of weeks. Be well.